Anyways, I'm talking about ES6, JavaScript, and ChakraCore today, and I have not much time because I just wrote these slides and I got a bit overboard and put too many of them in. So it's going to be a surprise for me as well what's coming. So share your food noisily. And is it a drug deal going on, or is it just... Yeah, okay. It's not the snooze stuff, is it?
No.
Okay, good. Because that's just disgusting. I'm sorry. We can talk about that for hours. Anyways, I'm Chris Hyman. I'm Code Poet on Twitter. In case you don't have enough pictures of kittens and lynx and hedgehogs and things in your life and information about JavaScript, you can go there. I basically live on that thing at the moment, it seems. Let's talk about JavaScript, and here are the things that I want to cover today. The old issues, the learning process, the library framework issue, the ES6 buffet, standards and interoperability, breaking monopolies. So that's the things that we're going to go through, and we don't have much time. So let's start with the old issues. I've been using JavaScript since its inception, more or less. I mean, 96, 97 when I built my first website, and then I went from Perl to JavaScript because I can use it on the train because it worked offline. I didn't need a server, which was pretty cool. And then I realized it's not fun to actually write DHTML where you have like pop-up windows that write a frame set out in the pop-up window that has to read a cookie from another server and these kind of things. So then I gave up on it a bit and went back to PHP, and then when I joined Yahoo, I worked on YUI and worked with, the great thing about Yahoo is when you work there as an engineer, you do a project or a little project and then you get your first code review after that. So we know what kind of training you need and what kind of your knowledge level is, because everybody can bullshit in the interview, but we wanted to make sure that people know. So I was there as a youngish engineer. No, I wasn't young. As an engineer in Yahoo, and my first review comes and they're like, so who's my reviewer? And they're like, Douglas Crockford. And I'm like, but he found one semicolon missing. That was all he had. I was like, yes, this is good. So JavaScript client side has issues. The first one, it's not fault tolerant, and that makes it a terrible language for the web. CSS and HTML both are fault tolerant. If in HTML you put an element around something the browser doesn't understand, it just shows the content of that element and says like, I don't know what you want, fine. If you do a p tag and you don't close it, the browser closes it for you and does these clever things for you. Probably makes you not a good developer, but it doesn't break the web of bad developers doing things, and sadly enough there are a lot of bad developers out there. CSS is the same thing. If CSS finds something it doesn't understand, it just goes and goes to the next line and goes with that. In JavaScript, every line with an error, it says like, oh, the God has forsaken me, sky is falling down, I'm not going to do anything for you anymore because I don't like you, and basically your thing stops. So whenever people talk about JavaScript, relying on JavaScript with everything, there's just too many ways JavaScript can break. And it's not about a one-off situation. It's not about binary JavaScript being available or not available. It's about what the browser can do, what the environment can do, what other people do with you as well. Because many different parties mess with your JavaScript. This could be your mobile phone provider, this could be the browser maker, this could be the operating system provider, this could be the hardware provider that your JavaScript runs on. You never know who's actually interjecting your JavaScript by the time it comes via HTTP through the wires into your end user's computer. So unless you have it on the machine directly, like in a Tesla board or something like that, you have no control over the delivery of JavaScript, which means there's a lot of error possibilities. You don't know the environment it runs in, and when you tell people that they need a certain browser to build to use your product, then you haven't built a product, but you built a prototype. Because in essence, nobody should tell you what browser to use. This is how we defined the internet. Yes, there will be people on terribly old computers. Yes, there will be people on the browser that you don't like, but it's up to you as a developer to put an if statement around the thing and only give the functionality to those environments that can, and not give it to those that can't, instead of telling people you should download a new browser. When I'm on a bad connection somewhere in Africa, India or Bangladesh, or I'm on my great mobile phone somewhere on roaming, and you tell me this doesn't work in this browser, please download an 80 meg browser, that's not going to happen. Not for your website, because it's not that important. It's always been part of the browser and dependent on its release and upgrade cycle. That was the other issue as well. We always, as JavaScript developers, new APIs got defined by the W3C, by the WAT working group, and we're like, oh cool, I want to use this. Well, it's not in the browser yet, and in this browser it's not there, and then they have these like NHS in England, for example, or like banks here, where it's like every 5 years we make a new browser in our company, and you're like, really? they're all evergreen, please do that. So that has changed a bit, but it was a problem in the past that JavaScript got a bad reputation because of the browsers it ran in, not because of the language itself or the APIs that the standard defined. The language has issues, which I call opportunities, and other people call issues, because we always try to make JavaScript not JavaScript. Every other language provider more or less wanted to turn JavaScript into their language. Like, why doesn't it do the thing that Python does? Why doesn't it do the thing that Ruby does? Why doesn't it do the thing that Perl does? No, nobody asked that. But many people wanted it to turn it into something else all the time, forgetting that it would break backwards compatibility and it would break everything that is already on the web. You cannot remove JavaScript from the web or replace it with Python. You probably can now in a binary format if you run it through ASM.js and Emscripten and all kind of stuff, but then you're just a terrible person. And you got things like type of not a number is number. You know, these kind of fun JavaScript bits where you just look at the thing, like, what happened there? This is so weird, and there's a whole like WTF.js talk about all these little bits and bobs that are going wrong. But this is kind of like, yeah, so, you know, it's very funny to do it at events, but in day-to-day life, this will never catch you. Whereas like having an object, and having an array instead of an object that I can overload and inject something into your JSON payload, that's something that will catch you. There's no type safety. That's what people always wanted when they came from Java and other languages, because type safety is, first of all, it seems cleaner. It seems like, okay, I know this is a string, and of course, for memory consumption, it's much better because the browser doesn't, the compiler doesn't need to guess what it is and say like, okay, I give you as much space as needed because it could be whatever. It could start as an integer and turn out to be a crocodile in JavaScript after half an hour. There's no classes. I mean, people say JavaScript has no class. That's a bad joke. And a lot of it is not that needed. Prototypical inheritance, if you know how to use it, is very powerful, but classes are the things how we get things taught in school. So instead of going back and changing the school system, which of course is not needed because that hasn't changed in 50 years, why should we do that in an environment like the web? We said everything has to have classes as well. And it feels rushed. Yeah, the language was defined in 10 days. And I'm quite sure that there was alcohol involved and all kind of stuff. And talking to Brandon Ike, it's like it was a thing that there. I mean, just the name, you know, JavaScript, because Java was cool back then. Could have called it Simon or something like that. No, but for years and years you got the wrong LinkedIn offers because it's called JavaScript. You know, like, but nowadays at least they don't call JavaScript anymore. They just ask for React and 6 years experience in it. The first problem is that leads to engine trouble. Because JavaScript is so flexible, the compiler and the engine has to do a lot of stuff to make it work. So with a type-safe language and a class-based language, I know what kind of memory consumption I need. With a just-in-time compiler, I always need to do things, which makes JavaScript slow for a lot of people when you compare it to C or C++ or other languages that are much more, you know, type-safe and all these kind of things. Which of course is a problem in the Internet of Things. Because there we don't have any massive processors, we don't have much RAM, we don't have much hard disk space, so we need to have code that runs as quickly as possible, which is why we started using binary code in JavaScript as well with things like WebAssembly and all kind of other things. But we found that actually by changing the compiler, the JavaScript compiler and the just-in-time compiler, and making it, for example, optional, or giving it a threshold to only do so and so many threads or so and so many operations, we found it actually runs nice on IoT devices as well, whatever they may be. We're still confused about this, what IoT actually means, but it sells tickets for conferences and people can give talks about it, so that's good. I'm not bitter about this. I'm actually working on a few things, but I find it so hilarious that everything is IoT now. And you're like, yeah, what does it do? Well, it's IoT. You know, like wearables, like how many watches do you have at home that you never used after you tried them once after getting in at a conference? Same here, like don't have a watch anymore. Now, the biggest problem that I found with JavaScript is the learning process, because hiring JavaScript engineers is damn hard. Because most of them are either like think jQuery is JavaScript, or others say like I only work in that environment and I don't use a computer like that, and what do you know who has 16 years experience? I should get double the money that you get. The JavaScript learning process has always been rather interesting. Back in the days we just used view source to see what others are doing. That's the cool thing. This is how the web grew. This is the really amazing thing about the web, because you couldn't hide your code. You just saw somebody else did something cool. I look at the source code and I see how it's done. Then I copy and paste the bits that look like they're responsible for some things. Then I change some numbers around, and then I run into errors, and then I blame Internet Explorer. That was basically the learning process when I started with JavaScript. Of course, after a few years later on, we're actually much better at that. We now search for a solution on Stack Overflow, and then we copy and paste the bits that look like they're responsible for some things. We change some numbers around, we run into errors, we blame JavaScript for being a terrible language, and then we blame Internet Explorer. And I love this one the other day, where it's like the one true JavaScript exception handler, try something, catch, window location, href, Stack Overflow, search for the thing that happened there. And of course, when you put this on Twitter, somebody else will make an ES6 version that's much shorter and does the same thing. But it's sadly enough true. The amount of stuff that you see copied and pasted from Stack Overflow, which I call the full Stack Overflow developer, is just ridiculous. And that's why I find it so hard when the bad solutions that give you the immediate results are the ones that get uploaded. Nobody wants to learn, wants to have an example that teaches you something. They just want to have an example that gives you the solution. They're like, oh, there's magic pixie dust in there. Cool, I use that one. And then you see problems being exacerbated over the years and repeated and repeated. And with ES6, we now have a clean slate. And I think it's time to actually put the foot down and say, like, you know what? Learn ES6. Start with that. Start with the cool stuff that ES6 gives you, like block level scoping, promises, all these little things that make much more sense and make JavaScript much more readable, rather than sending somebody or giving somebody the 1995 O'Reilly book and like, and now learn about JavaScript and what's an iframe, when you're like, don't touch that stuff any longer. So we have a great opportunity now that there's good materials out there as well. Battle.js is a preprocessor, and I'm going to come back to that one, but that's a great way to actually, the documentation in there explains you what all the different parts of ES6, ES 2015, ES 2016, ES7, whatever we call it, are doing right now. And it's a live REPL, so you can actually type things and you can see what the original JavaScript was. So even if you know the original JavaScript, this is a good way to get to understand what these things mean rather than going through a massive course. There's also Nicolas Bevacqua did a very good 350 bullet points. He just basically in the whole last summer he just wrote a daily post about ES6, and there's little nuggets of like information there that actually don't overwhelm you, but actually have all the information that you need. And Axel Rauschmeier wrote ES6, Exploring ES6. I'm one of the editors on that one, which is available for free online to read. And what I like about this book, and I'm not endorsing it because I make money with it or something, because it's free online, but you can buy it and give him money, not me. You can give me money as well, but that's just by the by. I love that the book explains the ES6 parts and the history of them, saying like, okay, this is now like this, it used to be like that, but it didn't work for Apple, it didn't work for Microsoft, it didn't work for Mozilla and these kind of things. So it shows you the discussion around the language as well, and not only the like, here's the future of JavaScript and you should use that now, but you can't. You know, like most other libraries do right now. There's a lot of tutorials out there like, oh, this is how it works, but it's not usable yet, but it will come. And you're like, no, I'm sorry, we don't have time for this, we've got stuff to build. So, which brings me to the library and framework issue. This has been around for a long time. It used to be the Ajax world where they got like all the Ajax libraries, and now we got frameworks and libraries for everything. And it seems to me fashionable to make a library instead of just writing code. And there's a fallacy in making things generic. We always, as developers, we think making things generic makes them much more useful. But in essence, the more complex we make things, the more generic we make it, the more documentation we have to write it, the more we expect people to care about as much about the thing that we do. And that's why you see, for example, yesterday we had a discussion on Twitter, people wrote shit on Twitter, about static page generators, you know, static pages. You know, HTML is static, you know. There's 412 JavaScript static page generators out there in comparison. And we found out that 73% or something don't work right now after half a year. because they never bothered to keep the thing up to date, and it was relying on something that was only in one browser and didn't come into the standard and these kind of things, and Node had a problem with the others. But yay, cool, we got 412 of them, because more choice is always a good thing, because all of you have time to compare 412 things when your project manager tells you, we need a static page. JavaScript abuse is rampant. I love this demo. This is nasa.gov in America, and when you start that on a normal connection, you get black screen giving you the idea what space looks like and what being in space is like, the enormity, and then it starts giving you some things, and then it starts spinners and loaders, and then it starts loading the content in there. It's 14.8 seconds to load the page, which doesn't sound much, but this is a 25 megabit connection. Try that on your mobile phone while you're on roaming or something like that, and that's a government website. People paid with their dollar bills for that, with their taxes for that. It's 3 megabytes of unminified JavaScript, because they put Ember and jQuery into one file and put it in the header of the document, instead of at the end of the document or loading it as a module and these kind of things. All the things we talked about in performance sites. This is not bad engineers. This is a press release having to come out on a certain day, and they had to do it quickly. This is how most of the errors happen on the web right now, because we who know the things are not the people who have the choice to do it properly. So whenever I talk about library dependency and these kind of things, people are like, yeah, but should I write everything from scratch every single time? And my answer is, why not? You know, from time to time, that's probably not a bad thing. My first computer didn't have a way to save anything. So I wrote the same program about every 2 days, and I got really good at that program. And it sounds like a waste of time, but it made me the better developer that I am now, rather than like relying on 12 things that I don't understand and then complaining because they don't work. And I don't even know why they don't work. Of course, the other side of it is like we now take things that we had in Java for a few years and we put it in JavaScript with a massive over-complexity about one framework dependent on another, and then it's full moon hopefully, and your hard drive must be 60% full and not like 20% full and these kind of things. So you got more and more steps coming into the JavaScript world as well. Debugging JavaScript has become a total pain. Like trying to find an error, just you jump through like 12 things. It used to be like that in advertising. When I worked at Yahoo, I had to do security reviews of advertisers to see if they don't inject malware, and it was like an iframe writing out another iframe, writing out another one that loads something into an image tag and these kind of things. And by now, some of the build scripts that we do look exactly like that as well. And then you get people saying like, our node on Windows is crap because I can only go 32 levels deep in the folder structure. Like, what? Who wants to debug this? What are you doing with 32 nested folders? Or it just happens, I don't know why it's that way. And dependency hell is what we call it. And there was a good talk by Stefan Bönnemann at JS about how this is kind of like a first world problem. We're making that problem ourselves, because dependencies are a problem. But in essence, if you don't write your unit tests properly, then it's your mistake and not the dependency's mistake. We're going full speed on innovation, componentized web, extensible web manifesto, WebAssembly, WebGL, Post-CSS, progressive apps. There's cool stuff happening. And all of this is very important, and all of these are very, very important to standardize and to make work across browsers. The problem that we have right now, instead of waiting for this to happen or testing it out in browsers, we just write a magical library to make it work for every browser right now. By that way, making us the person that owns that problem rather than the browser makers. And that's a big issue, I think. Because building libraries and frameworks that magically fix things has become fashionable. It's like, it's not about releasing a library that people use, it's about being on Hacker News for the day and being the person that recreated that thing. We work around browser issues. We make web standards of tomorrow work today. We build solutions to clean up others and make them smaller. You know, instead of forking another library and fixing it, we write another library and say like, this is 4K smaller than the other one, so don't use the other one. You're like, it's on GitHub. Why didn't you just fix the other one and have a conversation with people? Oh, I know what the problem is. You have to talk to people instead of writing code. And each of those comes with a don't use in production label. That's my favorite. You know, it's like, you always go through the documentation, and then at the bottom, just above the made with love somewhere, is the like, oh, by the way, don't use this thing. You're like, what did I just waste an hour for trying to understand what you're doing here if you tell me I cannot use it in production? When are we going to use it in production is the question. And it's not safe for work to use these kind of things. I love that picture. It's just really. And that is something that is not innovation to me. Sooner or later, we have to understand that we're a delivery company or delivery market as well. We build interfaces for people to get content and to create content. This is what we do. Everything else is secondary. And 90% of our innovation right now is about making our life as developers easier. You know, we get paid for this. You get paid for things you don't want to do. That's why we also should be thinking about our end users more, not ourselves. But it's cool, go nuts and play with technology any way you want. It's totally fine that we go crazy about these things, but I'm getting slightly tired of people telling me that this is the better solution because somebody put it on GitHub yesterday than the solution that came from a company that is in use in several products. I worked on YUI, I'm not bitter about this, I am. But it's basically, we ran the biggest website on this planet on this JavaScript library for 4 years. And nobody wanted to use it because jQuery was much cooler. jQuery gave you faster results, it's really good. YUI was over-architected, it looked very brutal, but when I see NPM now, how that's done, it's exactly the same architecture. So I guess we moved a bit as a market. Frameworks are great, they're fun to use, and you achieve a lot very quickly. It's much easier to start with a React to-do list and put a logo on top of it and sell it to your client and write a to-do list for them or something like that. You build complex apps in a matter of minutes. They work around pesky browser bugs, that's true, but with evergreen browsers, those browser bugs are like for a month nowadays, not like 10 years like they used to be. And they're good on your CV, of course, like putting a library on there right now is the best thing you can do. They also come with developer costs though, because learning new frameworks costs time, especially when they're not compatible with their old version, not naming names here. Relearning new frameworks is also a problem if the next version is completely incompatible and throws random errors that don't even have proper error names. Debugging frameworks is problematic because you should not have to, but a lot of times the errors in your app come from the framework rather than from your app itself. And setting up developer environments costs time and money as well, because out of a sudden, oh, you need this. I gave a talk this morning about image optimization, and I found this one script that was, okay, it's server-side image optimization, and it needs to run on an OS X machine, and you have to have these 5 binaries installed. I'm like, yeah, I have an OS X machine, but my servers are all Linux, and none of those run there, none of those things are available, so that's not optimization. Cutting down on possible hires, adding to the onboarding time is another problem with this as well, because if you say we're a React shop, out of a sudden you can only hire React users, or you actually have to coach them the first 3 months or 3 weeks or 2 weeks, depending how good they are, to learn that environment. And when they leave, all their knowledge goes with them as well, and you have to ramp up the next person again. So that's another issue with that. We should consider the effects we have on our end users as well. Time to load, execute. Bandwidth used, CPU usage, frame rate, 60 frames per second, memory usage, and of course battery life and the battery hunger is a very important part. Just because it's easy for us to build something in that environment doesn't mean much if our end users have no battery life on their phone and cannot use it any longer. So test your stuff in the worst environment possible. Then you write some good code. Don't test it on those cool machines. Get yourself a really, really terrible Android phone and bad connectivity and test your stuff on that. I'm not saying Android is bad, I'm just saying they're cheaper than the really, really horrible iPhones, which don't exist. Anyways, there's a great talk by Paul Lewis from Google about you should use library framework, it's the bestest. He did some really good research into how much it costs you in terms of developer time and these kind of things for libraries to be used. And he also went and looked one of the myths that is going around that the DOM is slow, like DOM scripting, vanilla JavaScript is a terrible thing, that's why you need a virtual DOM, that's why React is so cool and all the others as well. Which, yeah, they are, if you build Facebook, or if you build something in the size of Facebook. But for a static blog, for example, React is a bit overkill, although it's cool. So the bottleneck is almost always the DOM mutation and not the JavaScript execution, is what React documentation says. So he built this thing where he had like 100 pictures, and then he loaded more and more the more you click, like 1,000 pictures, 2,000 pictures. All of these images have like 5 HTML elements, so they're divs with like an image in there and stuff. And then he did timers. So he started the timer at the beginning of the loading of the page, And then when the framework started rendering, then it stopped the first timer, and when the DOM manipulation ended, he stopped the second timer. So we know how much the DOM manipulation was and how much the time in framework for the framework to be loaded, to be executed, and to actually interact with the rest of the page and create the virtual DOM and spit it out as one string. So the more pictures he took, the more pictures he used, they found that the DOM manipulation, the red stuff, stayed more or less the same. Whereas the virtual DOM and the generation of the string and the generation of the framework got bigger and bigger and took longer and longer because it generated a new DOM every single time. It didn't pre-cache, it didn't use the cache of the already used DOM because it is a virtual DOM, it's not the one that the browser does. Whereas V8, in this case, in Chrome, the more it actually took, the less time it took because the old ones didn't change, so there was no mutation going on, so it just used the cached DOM objects of that rather than creating them anew every single time. So the vanilla JavaScript was the faster the more images you used, which is kind of weird, but this is where JavaScript engines get clever. He also built a system called BigRig where you can analyze that in detail, but I'm not going to go there now. And he used different frameworks and showed you how long the bootstrap time and on an N5 and on an iPhone was. And these are the costs that we talked about. And sometimes, for example, in Ember on an N5, that's two seconds before the page started rendering. And that's not really worth it for our end users. This is just a terrible thing, because if something doesn't do anything for 2 seconds, I start reloading and blaming Talia and other people rather than you as a developer of the website. So a lot of times with frameworks, we use code we don't understand to fix issues we don't have, because we try to scale to size of Google or size of Facebook with the things that we build, rather than building something quick and dirty and making it fast and then scaling it when we have that problem. Scaling is not a ghost. Scaling is not something we should be afraid of. Scaling is a good problem to have. But you will never reach it if you already annoy the first users that you have with 2 seconds of nothing happening on your screen. Learning libraries and frameworks beyond Hello World costs time and money. And people don't understand that. They're like, okay, we use a framework so we don't have to get good developers. They can just use all the documentation demos and we're going to build things with it now. Sooner or later you will have to debug the framework as well. And that's the idea of an open source framework, that you give back to the framework and you help fix it when you use it, because you're getting free content. Time you don't spend on looking at optimizing your own code, and in essence we value developer convenience over user experience. And that's something that is just sad, I think. Now, talk about ES6. A lot of people get overwhelmed with ES6, especially old school JavaScript developers, when they see all the things that are happening there. What you have to understand about ES6 is that it's a buffet. ES6 caters to many, many different end users, and not only the JavaScript developers that do client-side JavaScript with like forms in a browser. JavaScript has moved to the server side with Node.js, and that way we had to do a lot more things than we had before. So JavaScript evolved in a really weird period. It's like 1997 we had it, and 1998, 1999, and then we had like 8 years of random stuff and Flash and things like that happening. And people are like, yeah, we don't know what's happening here. In 2009 we have ECMAScript 5, and that one got stuck with us for a long, long time, actually 5 years. And in 2015 we finally have ECMAScript 6, the new version of it, the ratified version, not a pre-compiler, some extra version on top of JavaScript. This is now the JavaScript that everything that says it runs JavaScript will do. And ES6 actually gave us significant changes. It's backwards compatible. That's very important as well. And it also means that we had to do a lot of painful things in the language that we wanted to do differently, but we cannot, because we cannot break the web. We never can break the web because we're all dependent on it. Ratified, and it's quite fun because it understood a few of the problems that people had. Like this, for example, confused a lot of people in JavaScript, where it's like JavaScript makes me want to flip the table and say, fornicate this, but I never can show what this refers to. So, and that was the problem with like timeouts and closures. So when you had this one here in a timeout, this actually it was undefined because it's in another closure of the set timeout. So that way you had to actually do it with a timeout, and you had to do it with a call to get the ID, or you had to do a bind this and a 100 millisecond timeout to get the ID. And that's why in ES6 we finally have these arrow functions which keep this scope to the outer scope of the timeout that I was in there. So that's much easier to use right now, and it's a problem that we don't have any longer. I have a real problem with that. I love the idea of it, but being an ex-PHP developer, now looking at JavaScript code, with that code, I'm always confused what language I'm debugging. But that's going to be a few months until I get used to it as well. It's also saving us a lot of keystrokes, because you have like a wonderful thing like a map, for example, over an array. Instead of having these anonymous functions that nobody understood why the hell they were there, we now just have the arrow and that's it. So we have this fetish for not writing long code. I don't have a problem with long code. gzip will sort a lot of that stuff out. What I have a problem with is code that is so cryptic and short that I cannot debug it, or code that is so long because some C# developer did a JavaScript method like this long or something like that. The right amount of code is the amount of code that makes it understand. Everybody can write code for a machine. A good programmer can write code for another programmer to understand. And always think that the person that takes over from you is a horrible, horrible person and will do unspeakable things to you. So make sure that you write code that you can be proud of, because probably it will be you in half a year's time looking at your own stuff and going like, what did I do there? ES6 comes with so much goodness, it has to be fattening, and all of these things are for different bits and bobs. The arrow function is syntactic sugar, template strings, that's cool as well. We now have templating in JavaScript, so we don't have to use mustache or all kind of libraries for that anymore. Then we have scalable apps where we got the let, constant, block scope bindings. We have classes, promises, and so on. Typed arrays, modules. Const stuff, that's really, really cool for scalable apps, because your memory consumption will be a lot less if you use those. And then for library builders, we have all the really cool stuff like proxies and symbols and subclassable build-ins and whatever that other stuff is, map set and weak map. So a lot of these things came from other languages into JavaScript, but you don't have to understand all of them unless you want to write a book about ES6. I urge anybody who really wants to learn stuff to write books. I used JavaScript professionally for 8 years, got a lot of money, got money for it, not a lot. But then I wrote my first book and I realized I didn't understand anything I was doing the last 4 years. Because learning it yourself and explaining it to somebody else means you have to understand it. You cannot just fake it any longer. And it's really, really refreshing for you as well. The old saying says, like, if you start teaching, you end up learning. And it's a really, really cool and refreshing thing to do for yourself. Support for ES6 is encouraging. Edge, Firefox, Chrome, Safari on iOS 9 now supports it as well. And this is cool because for the first time Safari is totally on board with everything as well. Because in CSS we have lots of fights with Safari. Like, we're not going to do that because we have this that you could use. Well, we could if there wasn't a patent on it. But anyways, in ES6, for Safari itself and for iOS itself, it made sense for them to play ball, and it's great. And I love Safari people, I love iOS, I'm not saying this is bad. The problem for non-supporting engines, ES6 features are syntax errors. So if you put a fat arrow into something and you run it in an IE8 or something, it says like, that's an error, I'm not going to do anything with that. So what we do instead is do transpiling. So transpilers, Babel.js is the big winner in that, there were others as well before that. Converts your ES6 into ES5 or even down to ES3 if you wanted to. And that has a lot of beneficial things. It converts to older versions on the server or the client. On the client, this is dangerous because you never know how fat the machine is that runs your thing. On the server, it makes total sense. It's used by Facebook and many others, used in editors and tool chains as well. So Visual Studio Code and these kind of things have transpilation built in as well for you. There's problems with it. Every step between writing code and running it in the browser, the code that is executed is not the one that you write. So if there's a problem with that, it's actually up to you to understand what the transpiler has been doing. We don't run or debug the code we write. We hope the transpiler creates efficient code. It does, but we also have to keep the transpilers up to date, which might be a problem if you have a distributed system. We create a lot of code. Transpilers create very creative code, but also a lot of code. And sometimes this is just doesn't really make sense for the fat errors that you want to use. And browsers that support ES6 will never get any. That's the biggest problem with it, because we just compile everything to ES5, so we cannot even tweak the engines of the browsers because we never get ES6 code to run. And transpiled code can look funny. This was fun. Reading JS code that ends with this. And then Perl has a bad punctuation reputation. So if you got a Perl developer calling you out on bad syntax, then something went wrong. But this is not code that somebody, hopefully not code that somebody wrote by hand, but that came from Webpack actually, that generated that code. So we have that problem that view source is not the view source it used to be anymore. You don't know how many compilation steps were in between. There is another blog post that came out yesterday about comparing the speed and the cost of transpiling with different, like there's lots of ways to transpile, and this is like the gzip size, the compile and execute milliseconds, and the runtime milliseconds. So you also know how much it costs for the end machine or your server to do the transpilation. And again, it's a matter of asking yourself, is it worthwhile for the amount of code that I write? Because if it's not 100,000 lines of code, probably not. The ES6 conundrum is we can't use it safely in the wild because not every browser supports it. We can use TypeScript or something or transpile it. We can feature test for it, but it can get complex very quickly. Browsers that support it will not get an ES6. And the performance is bad right now because most engines cannot be optimized for it, but we need ES6 to run to actually do that. Tricky. Which brings me to standards and interop. What does this code do? This is the follow button of Twitter in your machine once it's been completely compiled and everything. It's like 2 meg or something of JavaScript. And this is not, again, Twitter being bad engineers. This is because they have to support every environment out there, and it has to look pixel perfect in all of them. And this is terrible that we have to do that, and we have to stop doing that. Because supporting old browsers pixel perfect is a really stupid idea, because it's just wasted time, if you think about it. This is the code how it comes to you if you actually use it, and this is what it turns it into, these kind of things. Replacing built-in functionality for the sake of control is something that we keep doing because we want to have it the same as in every browser. That's not how the web works. If your code looks the same and feels the same in every browser, you've built something terrible. You didn't build something for the web. It should be working in old browsers, and it should be beautiful in new browsers and good in new browsers, and it should be memory management and performance management in all of them. Yeah, it's hard to do, but welcome to the web. This is how you get millions of users. But don't give all of them the same experience. That just means you give everybody a disappointing experience. Simply because we can fix anything with JavaScript does not mean we should fix everything with JavaScript. Yes, you can create a button that looks the same everywhere if you create it with JavaScript. But if you don't create that button with JavaScript, it's also accessible to screen readers. It also works when there's a JavaScript error. It's a button. People should never click a button that doesn't work because that's a broken promise to your end users. The compatibility race is a big problem right now, and it's getting better. It used to be really terrible. So we did this visualization of the standards that came up in the last year. So we had like IE11 and Chrome and Safari, and the one in the middle is the standard. And people invent new things all the time, and we try to be better inventing things, and then it does not get into the standard, it gets into the standard. This is not helping us really. And the fanboying about like saying this is the better browser, this is the better browser, I don't care. I really don't care what browser you use, as long as it's an evergreen one, and as long as you don't tell people to use that browser. Yeah, I mean, there's tricks to do. Like if you find somebody with an old Internet Explorer and you actually install a new Firefox and you just change the icon of the Internet Explorer to open that Firefox, that's a good thing to do. But telling them that they need a new browser is not a good thing to do. It's a vicious innovation circle. Developers don't use features until browsers support them, and browsers don't add new features unless there's demand and use in the wild. So as browser makers, if nobody uses the thing, we don't see any point in putting that in there. And then developers don't use it because browsers don't have it. So we have to break that cycle somewhere. And that means using the stuff and not using a library that actually works around it. Or using a library that uses the new things when they are in use. Or using a library and doing a fork for that and tell them to use the new things and doing it for them. Many ors. Out-of-box browsers do not suck any longer. That's the good thing. Even on Android, the newer ones are really, really good, but we had a big problem in the past with cheap Androids and every mobile phone provider and every wireless provider coming up with their own Android version. I've got an Honor, a Huawei one. I don't know what the build of Android in that thing is, but it drives me crazy every single day. Nice phone though, so I'm waiting for CyanogenMod to come out for it. Compatibility is on every browser maker's radar. I love this in a company in England, like, are we not testing on Edge? There's no bugs tracked against it. We're testing, but we didn't find any bugs. And that's by design. The Edge browser is the browser not to care about, because we put so much compatibility things in there. We had to put so much dirty code from other browsers in there that we basically said, okay, we cannot break the web, because if Microsoft does it, it's horrible. If others break it, it's called innovation or something. But we had to put like CSS gradients from Safari in there. We had to put other bugs from Chrome in there. We had to make sure that the browser behaves nicely, and that's okay. We get paid for that. As I said, we get paid to do painful things, so why not doing them? The last one I want to talk is breaking monopolies. The problem with Internet Explorer, and I said that for years and years, was that it was hardwired to the operating system and it was the #1 browser on that operating system, because end users do not care. They install browsers if it comes with an update of Adobe Reader and tells them you don't need Adobe Reader if you have that browser, and they're like, great, so I don't have updates every 2 seconds, that's probably a good thing. Or they wanted to use services of companies like Apple and Google, and they were only available in those browsers. Other than that, people don't know what a browser is. They click on an icon and go to the internet and see what the weather in Oslo is like or something like that. So when we made a browser out of the box, an evergreen browser as well, instead of one that is tied to the operating system and never gets upgraded, this is when I joined Microsoft and I said like, yes, I wanted this for years and years. Let's do this now. And Android does the same now with the evergreen browser and even the update of the web view. So that's pretty good. So every time you have a monopoly, I think it should be broken at least with a second player. Now, when we created the new JavaScript engine for Edge, we came up with a very, very intelligent way, and much more intelligent than I am, so we can take there's a 90-minute talk just about this, where it shows that the just-in-time compiler is now not only one, but actually 3 of them, and 2 of them are simple just-in-time compilers that don't do the sweep, but just do a normal compilation, and they're all in different threads. So that way we have a concurrent way of running the JavaScript, and we ended up being much, much faster than the original engine in Internet Explorer, and we also managed to make it much, much less memory hungry. That way we actually are good to actually run this on IoT devices. For example, Raspberry Pi 2 runs Windows 10, and I do a lot of stuff with it right now, and that's pretty amazing that this thing runs it. The speed comparisons don't care about Canary or Firefox Alpha and these kind of things. What I really only care about is this one here, that IE 11 is basically outshined by Microsoft Edge. This is what I want, the new browser to kill this one. That changes every week. I mean, that's why I'm bored with like speed statistics and stuff, because everybody writes a new way of showing their browser is the better one. But I really, really wanted to make sure that the old Internet Explorer is becoming terrible to use, and there is a good way to actually get the new browser out there. Out of the box, Microsoft Edge is the browser. You have to find IE 11. It's still in Windows 10 because we have a lot of websites that need IE functionality. All the functionality we took out of the browser, like our own sites inside Microsoft, sadly enough. But it's only there when you need it, and it shouldn't be. Surprises happen though, because I mean, I'm a Mac user and I hang out in Node events and stuff, and I see only people using Mac. And then I talked to NPM, and they said 42% of Node.js users use Windows as their desktop environment. More than any single Unix. If you want developers to use your code, this matters. And I found that really cool. It also shows me that the people that use Node are not in the Silicon Valley, but they're actually in countries where people don't have Macs because they cost a lot of money. Like in Poland, for example, it costs 4 times as much as in America. It's just ridiculous at times. So what we did is we made ChakraCore, which is an even lighter version than Chakra, by taking out all the stuff that we have in the browser. So all the browser stuff, all the Universal Windows Platform stuff, and all the COM diagnostics APIs are gone, and only the garbage collector, the parser, the interpreter, the JIT, and modern diagnostic APIs are a new thing that we put in there into ChakraCore, created for ChakraCore, and into Chakra. That means we now have a way to debug JavaScript not only with console log, which in Node is super, super important because it gets very complex to debug asynchronous code in a synchronous manner with console logging and stuff like that. You just go through logs. It's like debugging Perl in the past. It's not fun. So again, this is very, very important for the Internet of Things because we made sure that the just-in-time compiler is on demand and also is capped to a certain amount of memory, which is something that we hope other engines will do as well. One thing they showed in a great video here, which I'm not going to have the time to go through, is time travel debugging, which means that instead of going through it step by step like you do in a step debugger, you can also step backwards. and it keeps the whole state of the application and the state of each of your objects and the state of the memory consumption for you as well. So you can go forward and backward in your debugging, which makes it much, much easier, again, with asynchronous code to find out what happened there. So this is coming into Visual Studio Code and Visual Studio, and it's also going to be in the F12 developer tools, and again, we're sharing this with other browser makers. We then went to Node and basically did a fork and said, like, here's Node with ChakraCore instead of V8, which was the problem. Node only had V8, one JavaScript engine, because for some reason the Odin monkey and all the monkeys from Mozilla never made it into Node. And I found this annoying because people wrote for one JavaScript engine, not for the JavaScript standard, because there was quirks in V8 as well. So what we allowed them is to write ChakraCore, and we wrote ChakraShim, which simulates a lot of V8 specialties that are not part of the ES6 standard. So you can actually run your V8 code with Chakra as well, but you have the faster engine with lesser memory consumption until V8 catches up, which it will. Then everybody wins again. So that's pretty good as well. I found it very interesting, though, that we put that extra shim layer in there, and it's quite disturbing how much Node code only works on V8, as if that would never change. That's, to me, very short-sighted programming. So Node using ChakraCore, the blue line is Node itself, and then we had Chakra was the orange line, and ChakraCore is the green line. So we managed to make it faster and faster over the years, over the month. And then we actually got it really, really into ChakraCore. We realized we're doing something really right here. So it's much, much faster than Node is with V8 at the moment. For example, we do TypeScript compilation of TypeScript itself, of Visual Studio Code, Team Foundation Server, Encyclopedia app. So all of these are the smaller ones are better. And the Chakra engine is not only in use in Edge, it's also in Outlook.com, and it's on the 356 Office things as well. It's on GitHub, play with it, file bugs, find bugs, tell us about it. It's yours to use, and you can even now, there's a binary install. If you use Node already, you can install it in parallel to your other Node installation so it doesn't clobber your code, so there's no problem with that. And that's all I've got time for, so thanks very much.